This is lesson 7 and it's on echoes. So what is an echo? So we all know that if you are in a cave or in a large hall or something and you give a shout, that shout sound will return to you. And that's what an echo is. An echo is a reflected sound, or a sound that is reflected from a surface. And generally echoes happen whenever sound is reflected from a hard surface, but it can also happen whenever sounds are reflected from other kinds of uneven surfaces, such as the surface of a cave. These are some uses of echoes. First one shows a fishing boat, and what the fishing boat does is it sends a sonar signal, which is also a sound signal, ultrasound signal, down into the water. If the signal returns quicker than expected, then there's a very large likelihood that there's a shoal of fish down there, and it's worthwhile the fishermen putting down their nets to see can they catch them. So they would expect that for the sound to come back from the seabed, it would take longer to come back, and therefore the echo time from the seabed should be longer than that. So they know if it returns sooner that there's a very good chance that there's a good shoal of fish there between where the boat is and the seabed. Second example here is just the use of echoes to determine distances. And what you can do is, if you know the speed of sound, so the speed of sound here in air would be 340 metres per second, and if you're able to time how long it takes for your echo to return to you, you can tell how far away the cliff face is by using the equation speed is distance over time. You just need to be careful. The time that you measure, the echo time, is a time taken for the sound to get to the cliff and back again, and therefore whenever you do your calculation you need to divide your distance by 2 at the end to make sure that it's only the distance between the person and the cliff, if you just need to know that distance. Last image here is just an image of an ultrasound scan. And ultrasound again is of course a sound, very high frequency waves, and those frequency waves, high frequency waves, are passed into the mother's body and they reflect off the baby. They come back to the probe again, and the probe sends a signal to the computer and it builds up a picture. And so you can see here a picture of the little baby, and you can see, if I scan in a wee bit you might be able to see it a bit more clearly. You can see the shape of the wee nose there and the mouth, and there's an ear here, and you can see parts of the brain even, which is fantastic because generally ultrasound's not very good at detecting something through bone. A lot of sound is reflected from bone, but a little baby's skull is very, very soft, and so therefore they can see very clearly into the head and the brain and just check everything seems normal. You can see the very white areas here of the ribs, and they would reflect, this is the shoulder bone here, up at the shoulder socket, and even that little hole there that you can see, that would be the stomach, and the stomach would have a lot of air in it, and therefore it comes up as black rather than white. So that's a very, very good use of echoes, and those in particular those are ultrasound echoes. So generally what you're asked to do about echoes is just to calculate probably a distance. So this is a question, you met this in your notes. The diagram below shows a fishing boat, and it's using sonar, which is ultrasound, to detect a shoal of fish. So they send a signal down, and the echo then is received 0.1 seconds after leaving the ship. And the question then says calculate the distance from the boat to the fish, and gives you the speed of sound. So you use the equation speed is distance over time. We are looking for a distance, so you again could use your little triangle to calculate or to rearrange your equation. And so because it's distance divided by time, and this is a dividing sign, then if you put distance there and time in one of the bottom ones, then speed goes in the other. So we're looking for a distance. If you put your finger or thumb over the distance, you can see there that distance is speed multiplied by time. So if I write down distance is speed by time, that's 1500 is the speed, and the time is 0.1 seconds. And so 0.1 of 1500 gives you 150 metres. But remember, that's the distance down and up again, so therefore the distance to the shoal of fish is only 75 metres. It's 150 divided by 2.